Okay, we're going to simplify this one. It's multiplying these two rational expressions together. And when we're multiplying these together, a lot of times what we'll find is that we can actually reduce this. And so in order to do that, what we want to do is try to factor out anything that we can. The 1 we can't do anything with, the x minus 9 we can't. Up here I've got this big long one. Now we've got a couple options here. Number one, I look at this and all of these share a 2. I can go ahead and factor out a 2 at this point, and then it would just be x squared plus 8x plus 15. And I could factor that one. That one would be pretty easy. I'm going to show you a different way to do it as well. Most students are try this route first, is the reason why I'm going to demonstrate this one. Down here I've got a 2x plus 6. It looks like they do share a common factor. We'll get to that in just a little bit. Alright, and really the goal here is to factor everything you possibly can first, then see what you can cross off on top and bottom. So let's bring this one out here then. This is our 2x squared plus 16x plus 30. If I wanted to factor this one just like it is now, and I can, the way we do that is we take our a times c, and then we have to find two numbers that equal a times c. Well, a times c, 2 times 30 is 60. So two numbers that have to multiply together to give you 60, but add together to give you 16. Well, that's 10 and 6. Okay, so we can do that. Let's go through here. But the very first thing that we need to do on these is to write down our 2x first. Now, we automatically write these down and we fill these in. This is the Berry method of factoring. You can use a different method if you'd like. Most students prefer this one. But 2x, you write out 2x in the beginning. Now, we know this is wrong because if I were going to multiply these two together, 2x times 2x gives me 4x squared. So I've got too many to begin with. We'll have to get rid of some later on. We'll kind of go through that. But two numbers that multiply together to give you 60, but add together to give you 16 are 10 and 6. So I'm going to just fill that in, and it doesn't matter which one you write them in. I wrote 2x plus 10 and 2x plus 6. I could have gone 2x plus 6 and 2x plus 10. That order doesn't matter there. Okay, now what we're going to do on this one is look to see if they have any common factors that we can take out here. And I look at this one and go 2x and 10, that has a 2 in common. I can factor 2 out of that one. So let's do that. If I factor out a 2, that leaves me just x plus 5. 2x plus 6, I can factor out a 2 out of this one as well. That would leave me x plus 3 over here. So notice how I left my 2's in just for the moment. Now, I know that I have too many up here. Remember, 2x times 2x gives me 4x squared. So I've got too many. I'm going to have to eliminate some. Now, if I eliminated both of them, then that would just leave me x plus 5 times x plus 3. Well, that does not equal what I've got up here. So this is where you're going to have to start thinking a little bit more and determine what do we need to cross off here. Well, let's see. If I crossed off one of them, if I crossed off the first one, then I'm left with x plus 5 times 2 times x plus 3. If I were to use the box method, or if you wanted to FOIL these two, x plus 5 and x plus 3, then multiply everything by 2, you'd end up with this original one here. And that's our goal. Remember, this has to equal what our original one here was here. So this is your completely factored form of this one. And notice how we don't cross out the second 2, and that gets a little bit confusing, but with some practice it'll get easier. Okay, so now I'm going to write this in here for right here, because I think that'll be the easiest route for the moment. Okay, now this is the exact same thing here. I just factored this one right here. All right, and I got that from right over here. We just did that one. Now I'm going to look down here, and I see that this one has a 2 in common. So I'm going to go ahead and factor out my 2 here. If I factor out the 2, what's going to belong on the bottom? Let's see, that's going to be a 2, and I'm left with x plus 3. Now, I don't get rid of this 2. If I did, it would just be x plus 3. That does not equal what I had up here. So that's going to be a key component here, is to try to determine when we get rid of that 2 and when we keep it. Alright, so we're going to keep it here. Now what I'm going to do is write this all over 1, because this is multiplication. I just multiply the tops, multiply the bottom, this numerator and denominator, and see if I can start crossing some stuff off. So there's my top here. I multiplied all that, and here's the bottom, x minus 9, and my 2, and my x plus 3. Now I'm just going to go through here and see what I can cross off. Alright, we can cross off the 2's for sure. Those are gone. I see also an x plus 3. Now, as long as I cross off the entire quantity, I'm okay. This is okay. So I do that now. It looks like I'm left with an x plus 5 and an x minus 9. I cannot cross off these x's because of this addition sign and the subtraction sign. If this were an x plus 5 and an x plus 5 on the bottom as well, I could. But it's not, so I can't. So I'm just left with x plus 5 over x minus 9. This is my final answer on this one. The biggest thing is to try to factor each one of these out as far as you possibly can, then start crossing off what's the same on top and bottom. Remember that it has to be exactly the same.